Hello there and welcome to A2 Maths from June 2018. We're on paper 2 and here we're looking at question 12, a trigonometry question. We need to prove that 1 minus cos 2 theta is identical to tan theta sine 2 theta. Now what I generally do is I like to pick the more difficult side and show that I can simplify it to the easier side, but in fact both sides here are pretty tricky. So what I'm going to do is I'm going to work with both sides and then show that the two things equal each other. So working with the left hand side, 1 minus cos 2 theta, well cos 2 theta could be a multiple different things. So in fact what I'll do is I'll work with the right hand side first, so I know what I should be turning cos 2 theta into. So tan theta sine 2 theta, well let's write tan theta as sine over cos and sine 2 theta as 2 sine theta cos theta. So sine theta over cos theta, that's what tan is, and then we times that by 2 sine theta cos theta. That's what sine 2 theta is. That's the trig identities, two trig identities I've used there. And what I could do now is I see that I've got cos on the top and cos on the bottom of a fraction, so those two cancel each other out. And then I get a final answer of 2 sine squared theta. Right, so now I know what I need to be turning cos 2 theta into. I need to be turning it into the trig identity that uses sine squared, and that is 1 minus 2 sine squared theta. Let's expand the brackets and I get 1 minus 1 plus, for the double negative, 2 sine squared theta, which is equal to 2 sine squared theta. And therefore what I've shown is that left hand side is equal to right hand side. I've shown that the left hand side is equivalent to 2 sine squared theta, and I've shown the right hand side is equivalent to 2 sine squared theta, so therefore left hand side equals right hand side. So there we are, we've proved part A. Now part B looks really complicated. Let me just write out the simplified, so let me write out what I've got in part A. 1 minus cos 2 theta is equal to tan theta sine 2 theta. Right, let's get cracking on it then. So we've got an equation to solve now, hence solve between minus pi by 2 and pi by 2 the equation sec squared minus 5 brackets 1 minus cos 2x is identical to 3 tan squared x sine 2x. Okay, so what I've spotted is that, well, it's not x's, it's thetas, but what I've also spotted is that I've got 1 minus cos 2x here, which is the equivalent to this expression here. So let's substitute that in. We're going to have sec squared x minus 5, and then instead of having 1 minus cos 2x, we're going to have tan theta sine 2 theta equals, no, that's not theta, it's x, equals 3 tan squared x sine 2x. Now what I'm looking to do here is I'm going to hopefully cancel some stuff out. Now remember that I can't cancel anything out if that fraction, if that cancelling out could be a zero value. Now I know that my value is in between minus pi by 2 to pi by 2. Can I cancel out sine 2x from both sides? Well, no, because sine 2x could equal 0 in between minus pi by 2 to pi by 2. Sine of 2x could equal 0 when 2x is equal to 0, or in other words, x is equal to 0. So as long as I count for the solution of x equals 0, then I should be okay, and I can now cancel out sine 2x from both sides. Can I cancel out tan from both sides? Well, no, because tan of x could also equal 0. When does tan x equal 0? When x is equal to 0. So as long as I still count x as 0 as one of my final answers, then I can cancel out one of the tans from both sides. Only one of them though. Right, so what am I now left with? I'm now left with sec squared x minus 5 equals 3 tan x. And this looks way easier to solve. So I've simplified as much as I can. I need to make sure I count the x equals 0 solution. and I've got this expression here that I now need to work with. Now sec squared, I'm pretty sure that I can use an identity to turn it into something to do with tan, but I can't quite remember it, so let's recall it. Sine squared plus cos squared equals 1. Now to get tan, I need to divide by cos squared, so I'll divide everything by cos squared. So now I have tan squared x plus 1 equals sec squared. So now what I'm going to come and do is I'm going to replace sec squared with tan squared plus 1. So tan squared x plus 1 minus 5 equals 3 tan x. Great, now I have a quadratic in tan. So let's move everything onto the left-hand side. Tan squared x minus 3 tan x minus 4 equals 0. Let's now factorize. We'll have tan x minus 4 tan x plus 1 equals 0. That's our factorized version. So we've now got two equations. We've got tan x equals 4 and we've got tan x equals minus 1. We know the solution for the right hand one will be minus pi by 4, and we'll need to use a calculator for the second one. It's in radians mode, so make sure your calculator's in radians mode. And we have x equals 1.326. Right, so there we are. Those are our three answers then. We have 1.326, x equals minus pi by 4, and remember the solution that we had from before, x equals 0. So there we are. Those are our three solutions to part B. And there we are. That's 9 marks for question 12 there. Let's now move on to question 13.